9.3b for algebra 2, number 13 on the back. The path of a grasshopper's jump can be modeled by a quadratic equation. Quadratic just means it's going to be an x squared. An average-sized grasshopper can leap a distance of 20 inches and reach a maximum height of 5 feet off the ground. Sketch a graph of this scenario in the space to the right. Label all important points. Calculate the a value of the grasshopper's parabolic path. Now, one tricky thing here, because of the numbers, it gave me 20 inches, but then 5 feet. I'm going to go ahead and convert this. I want to see that in inches. So I'm going to take 5 feet times the 12 inches. That gives me 60 inches off the ground. So 20 can leap a distance of 20 inches. That means starting here at 0, the grasshopper will leap and land there, which is 20 inches, and 0. And the maximum height is, here the highest point would be 60 inches. So this point, which would be the vertex, oh, that's going to be the y value, whoops. This point, which would be the vertex, would be half of this distance, which is 10, up 60. So the vertex is going to be at 10 and 60. Now sketch a graph scenario, space right, label all important points. There's my vertex. The root is 0, 0. The other root, 20, 0. So I've got that labeled and drawn. Whoa, you can't see that, sorry. Part B, calculate the a value of the grasshopper's parabolic path. So now the a value, remember they're talking about this a times x minus h squared plus k. I'm going to solve for a, so I've got to have the h and the k, the x and the y. The h and k come from the vertex, which I just found is 10 and 60. So I'm going to leave the a there, minus h, which is 10 squared, plus k, which is now 60. Now to get the x and y, I'm choosing the easiest point to plug in, which is usually the origin here, because I have a point at 0, 0. If I wanted to plug in the 20, 0, you absolutely could. I should get the same thing, but for this one, I'm going to do 0, 0 for y and x, 0, 0. This 0 minus 10 becomes negative 10, but I have to square it. Negative 10 squared is positive 100, so it's 100a plus 60 equals 0. I'm going to subtract 60 from both sides, so I'm going to get 100a equals negative 60. I'm running out of room. Divide by 100, so I get a fraction. Negative 60 over 100 is my fraction, but I'm going to reduce it. Cancel the zeros. When I reduce that, I get negative 3/5 for the a value. Now it says write a quadratic equation to model the grasshopper's path. Y equals negative 3/5 from the a value I just got. X instead of minus h, again, that's from the vertex. Positive 10 becomes minus 10 squared. And then plus k at the very end, positive 60. There's my quadratic equation for the grasshopper.